Hello guys, welcome back to my channel. If you are new here, definitely hit the subscribe button because we talk about all new technologies in this channel. So today we are going to talk about A/B testing. This is not just an introduction. We are going to cover everything you need to know from theoretical part to coding part. But don't worry, I'll keep it simple and fun. And look, I know what you are thinking. Oh, great, another boring statistical video. But here is the thing, this stuff is actually fascinating when you see how companies like Netflix, Amazon, and literally every major tech companies uses this to make huge decisions. Like Netflix uses this to decide which thumbnails get you to click on a movie. Amazon use it for literally everything on their website. Companies are trying to understand if changing something in their application will have a negative impact or a positive one on their end user. Let's say you are a marketer and you have two versions of welcome message in your website. Version A says 20% off on your next purchase. Version 2 says exclusive 20% discount just for you. So over here you can use A/B testing to make decision. Pretty interesting, right? So stick around with me because by the end of this video you will understand not just what A/B testing is but exactly how to do it right and when you should use it. Now let's move into our next topic. What is A/B testing? But I hope like you have got some of the basic idea and you are started guessing like what exactly is A/B testing. But let me give you a more simple example now. Suppose we have two options, A and option B, and you have to select either A or either B. Then you can use A/B testing to make out the decision. Go for another simple example. If you can't decide between two outfits, so you try both and ask your friend which one looks better, right? That's what A/B testing is. But instead of clothes, it is used for website, application, and advertisement. And here is how it works. Say you have a website and you are not sure if changing the color of the checkout button from red to blue or keep it red will have a negative impact or a positive impact on the end user. To test both the version, we'll split all our end user into two groups. One group will see the red button, the other group will see the blue button, and we will analyze the user behavior to find out which version is the best one. It's a smart way to make better decision using real result, not just guessing the things out. Now we can describe A/B testing as a tool or a method that help us to make better decision by comparing two versions A and B of some things like as we did and see which performs better based on user behavior. So now we'll look into why A/B testing is so amazing. First, no more guessing games. Real data shows you what works and data doesn't lie, right? Your user tells you what they like just by how they act. You don't need survey. They click and action says it all. Third, even small changes can make big difference. A tiny tweak can make more sale and more money and more customers. And the best part, you can test almost everything from email subject line to entire website layout. A/B testing help you to make a smarter decision backed by real data. I hope now you have got the basic idea of A/B testing. Now we will look into the testing techniques. Now let's explore some of the base techniques you can use in A/B testing. Starting with hypothesis testing, also known as traditional way of testing. Over here, before starting your A/B test, you should have a clear hypothesis. That is a statement about what do you think will happen. For example, I believe a change in the button color from red to blue will increase the click through rate. That means user engagement. Let's consider another example. If you have a clear hypothesis and what do you expect from the result, then imagine you flip a coin 100 times and you want to know if it's a fair coin. Then you would expect 50 head, 50 tail, right? But if you get 90 times head, then you probably think something is fishy with that coin, correct? The goal of A/B testing is to determine whether the changes you made have a real impact or if the result are happened by any chance or it's a pure luck. To do this, we use statistical significance. A common method is using a p-value. If the p-value is less than 0.05, it generally means the result is statistically significant, means the difference between A and B is likely not due to random chance. I will repeat one more time. Statistically significant means the difference between A and B is not due to random chance. It is purely based on real impact. Now, confidence level. This tells you how sure you can be about the result. A 95% confidence level is commonly used in A/B testing, meaning that you are 95% sure the result aren't due to random chance. It is truly based on real impact. Now coming to when to use traditional testing. When we have lot of user, when we want simple clear answer, when our team understand few basic math terms, when we can wait for the full test to finish. Good things about traditional testing: easy to understand and explain. Everyone in the business knows this approach. Give you clear answer like yes and no answer. And limitations of it: you have to wait for enough people before you know anything. Can't pick up a result at an early stage. It doesn't tell you how much better one version is compared with another version. Coming to our second testing technique, that is chi-square test. It is basically used for categorical data. Example: yes, no, true, false. So simply yes, no data like did they click the button or not? Did they buy something or not? Then we can use chi-square test. Think of it like comparing two pizza places. You ask 100 people, would you like to go to pizza place A or would you like to go back to pizza place B? Then you compare how many said yes to each. The chi-square tells you if the difference is real or just random by chance in all those scenarios. So when to use chi-square test? Testing if people click or don't click, testing if people buy or don't buy, testing if people sign up or don't sign up. Any yes no types question. Coming to our third testing technique, that is Bayesian testing is an alternative of traditional. In traditional, we were using p-value as a threshold, but over here we don't. We update our belief based on the data we collect. For example, instead of just saying yes, there is a difference, or no, there is not, it tells you something way more useful. There is an 87 or 90% chances that version B is better than version A. It also allows you to continuously update the probability of the success as a new data is collected, making it a dynamic process. This is particularly useful for ongoing experiment where you want real-time feedback. For example, you are watching a game, it's like having a scoreboard that update constantly instead of waiting until the game ends. So how does Bayesian works? Think of it as a confidence meter that keeps up updating as more people uses your test. So you might start at 60% confidence, then as the more user joins, then our confidence score increase from 60 to 75, 75 to 90, and so on. So when to use Bayesian testing? When you want to see result right away, you are testing lot of version A, B, C, D. You don't have tons of users. And when you need to make quick business decision, there are some limitations of it too. It requires some advanced statistical knowledge and specialized tool or software to perform Bayesian analysis. Now we will come into our next topic, that is sample size, and we call it sampling. Let's start with a simple example. Suppose you tried a new recipe. You invited two of your friends. One loves it, one hates it. Can you say if the recipe is good or bad? Not really, right? It's the same with the online tests. If you don't show your new idea to enough people, you can't trust the results. You might think something worked, but actually it did not. It's essential to randomly sample user to ensure groups are comparable. Here is how you can do it. Each user has equal chance of being assigned to either version A or version B. That's what is random sampling. This ensures that the two group A and B are similar in terms of demography, behavior, or any other factor that could influence the result. Now, once we had randomly assigned the user into one group, now what should be our sample size? How we should calculate it? It's important to determine the right sample size for your test. If your sample size is too small, your result might not be reliable. Then surely you need a lot more people in your test. Let's consider an example for selecting random sampling. So over here, can we consider this group of people for our testing? The answer is no, because only young people are there and only boys are there, right? Now, can we consider this group for our testing? No, only young people are there. Of course, we can see only young people, right? So we can't consider. Now, can we consider this group of people for our testing? Yes, because this has different age group of people and both genders of people we see. We can split the people now into two groups. The first one is A, the second one is B, and we divide it based on truly randomness, correct? So we have now truly random sampling. Tools like power analysis can help you to determine the correct sample size based on the expected effect size and statistical power. Along with random sampling, we have stratified sampling. In this case, you might want to ensure that the specific subgroups are represented in your test. Example, new customer versus returning customers. This is where stratified sampling comes in. It divides your population into different groups and then randomly samples from each group to ensure you have a balanced representation of all types of users. We discuss a lot about randomness our sampling because to avoid bias and to ensure that our A/B test results are truly reflective of how our entire audience would react to the change. Now we can use distribution techniques to find out how our data is spread out. So over here we can have normal distribution, t-distribution or other types of distribution techniques. So over here I have drawn a diagram of normal distribution which is symmetry because both sides are mirror image of each other, and the peak of the curve represent the average, the middle value, and the most frequent values. And with the distribution, we can also remove our outliners. Now let's talk about key metric. So what should you track in A/B testing? Or what should you actually be measuring when you run this test? There are there are four parts of it. First is conversion rate. Second is click through rate. We call it also CTR. Third is bounce rate. Fourth is average order value. So what is conversion rate? It is crucial. You don't look at the click only. You might get excited because in one of the version you see more clicks, but they don't check if those clicks actually turned out to be sale or sign up or whatever they actually wanted. So how to calculate conversion rate? Number of people who did what they wanted divided by total number of people who saw it into 100. Suppose we have 1,000 people who saw version A, 50 bought something, so our conversion rate will be 5%. Similarly, click through rate, CTR, that is also engagement number. The percentage of people who clicked on some specific buttons, link with email, advertisement, or others. And how we can calculate it? Number of clicks divided by number of times people saw it into 100. And it's matter only for email, marketing camp, banner ad, call to action button, where you put links and all. CTR high clicks doesn't always mean success if people click but don't actually buy anything on that. Now coming to average order value, if you are selling stuff, also looks at average order value. Sometimes the version that gets fewer sale actually makes you more money because people buy more expensive stuff. So how we can calculate average order value? Total money made divided by number of order. Suppose in version A 100 orders were placed. So and each order is made of $10,000 for example. So we made $100 on an average. Similarly, version B has 80 order but made $9,600. So our average order value is $120, which is more than version A. Version B is, and we also have like bounce rate, time on page, and other. Bounce rate is the percentage of people who leave immediately. Time on page is how long people spend looking at your stuff. Return visitor rate, are people coming back? This shows if they actually liked what they saw. How to determine if A/B testing works for your problem. Now that we understand both hypothesis testing and Bayesian testing, how do you know which one works for your problem? Here is how you can choose. For large sample size, if you have large sample size, traditional hypothesis testing is generally sufficient. It's simpler to implement and give you clear result based on statistical significance. For small sample size or ongoing test, if you are working on a smaller sample size, or if you need to make real-time decision as data comes in, Bayesian A/B testing might be better option. It allows you to update your belief as new data is collected, providing continuous insight. When testing multiple variations, for example A, B, C, D, then we can also adopt for Bayesian testing. What are the limitations of A/B testing? It's only test one variable at a time. This means you can't test multiple changes in single test. It requires enough traffic. It does not always explain why. You might need additional research or testing to understand the underlying reason. So, important consideration has to be made before doing A/B testing. First, sample size. Second, test duration. Third, avoid testing during unusual event. Don't run test during holiday, special promotion, or event that could affect your result. These factors can skew the data also. To sum it up, A/B testing is a valuable tool that help you to make data driven decision. Whether you are testing a website design, an email campaign, or a product feature, A/B testing gives you a real insight into what your audience like. But remember, it's important to plan your test carefully, track the right metrics, ensure your sample is random and large enough, and consider the limitation with A/B testing. You can optimize your strategies and improve your result. I will create a separate video for the coding part. And that's all about A/B testing. Thanks for watching. If you find this video helpful, don't forget to like, subscribe, and hit the bell icon for more awesome content. See you in next video.